Hi, guys. Good evening. We are back online. So far, what did we discuss the last time? Um, all right. These parts, I think it's all finished, right? So it's moment of inertia we have to discuss, isn't it? Yeah. Yes. Moment of inertia. Nice. So what is moment of inertia? So what is like inertia? Bro, what is inertia? Huh? Oh. It's the reluctant to the yeah for a like when the it's simply like when the mass is too much, right? When the mass is greater, it doesn't like to move, right? When the too much of a mass is there, like when if Johan was here, it's really hard to move, right? Because the mass is too much. And that is inertia. When the mass is too much, the mass doesn't like to move, the reluctant to move when the mass is too high. And the other way around, if the mass started to move, නේ එකපාරට mass එක move වෙන්න ගත්තොත් something went through. So if the mass started to move, again if the mass is greater, the reluctance to stop will be also less, right? The reluctance to stop will be more because it doesn't want to stop. When the mass is too much, it can't be stopped. Yes. Link වැඩනේ. Good evening, guys. Shiny, Johan. He's in the call. Yes. Hello. Bro, ne. අන්න කියන්න කරේට. Link එක වැඩ නැහැ කියලා. කොයි link එකෙන් දන්නේ ගියේ? මේ live එකට එවන්නේ නේද? නෑ මාක් හරි link එකක් දාලා ඇති. Guys, just give us a second because one of the link isn't working. People are calling. මොන link එක ගැන දාන්නේ? Bro, which link you are asking about? ඒක නෑ ඇඩ් කරලා නැද්ද? ඇඩ් වෙනවද? මේ පුතේ අතකොට දෙන්න. ඉන්න පුතේ මම මෙයාට දෙන්න අතකොට දෙන්න කියලා. කියන්නේ මීටින් එක තාම ඇඩ් වෙලා නැහැ කියලා. No, that's a message. Confirm your speaking language. I speak many languages. Most of the time. කොයි වෙලාවක හරි ජිම් එකේ කවුරු හරි මෙහෙම යනවා ඩින්ස් කරලා. inertia, that is also one of the inertia. Environmental chemistry. අපි ඒක ඉවර කරමු. අද බෑ. ඒක තමයි මෙහින් චුට්ටක් ඕනනම් හරිද? හරිද? right. බයෝ එකේ පොඩි ෆිසික්ස් නෑ බයෝ නෑ. chemistry part දෙකක් තියෙන. Isuka is coming. Environmental chemistry, full chemistry, and the elasticity is physics. So it's one of the chemistry. අම්මෝ night නම් ගන්නෑ බයෝ පාඩම් දාන්න. කට්ටිය නිකන් මේව ඩෙස් වල දිගහැරලා නිදාගන්න. ඔව්. ඒක different one. නෑ ඒක 2026 people. These people are 2025 people. ඔයා කියනවා නම් මේගොල්ලෝ යෝගොල්ලෝ එනවාද ඒකට පෝස්ට්? ඔයගොල්ලෝ කරාද පෝස්ට් එක පායලා තියෙන පෝස්ට් එක. අර orderly tute එක තමයි ඩිස්කස් කරන්නේ. Force seminar. just discuss the theories and questions and everything, you know. That doesn't matter, but on නැත්තම් එන්නත් එපා නිකන් තීරමන්නේ. Guys, is ko add වෙලා මෙයා නැද්ද තාම? නෑ නේ පේන්නේ නෑ. Still didn't decide because මේ premises issue ඈ? තුනෙන් පස්සේ. දැන් මට කමල්ලා morning තමයි දාන්න වෙන්නේ. කමල් බොස් then morning තමයි දාන්න වෙන්නේ. Trouble is the you know to me premises එක free නෑ. හෙට තමයි දාන්නේ ඉදී. premises එක free නෑ. තාම නෑනේ. කොල්ලදිලා? So shall we start anyways, right? So guys, now the inertia is the reluctance to move an object when the mass is high and the reluctance to stop when it's moving, right, of a mass. Now greater the mass, the reluctance to move and reluctance to stop will be more, right? That is why when you are in a bus, right, when you are in a bus, when the bus is taking over, what happens? To which side you are leaning? The bus is moving forward, you are leaning backwards. Why is that? That is the inertia. The mass doesn't want to move. So the bus is moving, but the mass of yourself will try to stay still. So it will go backwards because the system is moving forward. And what happens when you brake? Like what happens when the bus brakes? The bus will stop, but the mass won't. So the mass goes to the front. That is inertia. The reluctance to stop or reluctance to move. The greater the mass, that reluctance will be more. නේ ලොකු මෑස් එකක් නම් හයියෙන් ගිහිල්ලා බ්‍රේක් ගහුවොත් ඉවරයි. එතන ඉස්සරහා ඉන්න පොලිමක් විතර මැරෙනවා යට වෙලා. අර කන්දේකට යට වුණොත් ඉන්නේ ලොකු මෑස් එකනේ. Could happen. And that is inertia in the linear motion, you know. So when it comes to the circular motion, now the inertia in the circular motion is bit more different because what is the main difference of the circular and the linear motions? Axis, the distance. Yes, the distance matters in the circular motion, not in like the relationship. The distance matters in the circular motion, right? Because when it comes to the torque and the force, the difference is what? Torque and the force. Can you remember the torque and the force? You have to remember now. What is the torque? Yes, the FD, the force into perpendicular distance. So that is a torque. That for a circular motion, you need to give a torque, not a force. Force is not enough. The distance also you have to consider, right? So greater the distance, you have to only give a small force to make a larger torque, to make like a greater circular motion, right? Distance එක වැඩි නම් ඔයාලට පොඩි force එකක් දීලා ලොකු circular motion එකක් හදන්න පුළුවන්. Because that is a torque. There's a difference, right? Because the you know the torque is depending on the distance and the force together, right? So when it comes to the inertia, again, in the linear motion, inertia is depending on the mass. But when it comes to the circular motion, yeah, it depends on the mass and the distance together, the radius is. The mass and the radius together, which means the distribution of the mass, right? Which means the distribution of the mass, right? So the moment of inertia is depending on the distribution of the mass, and it is the reluctance to an object to make a circular motion. And when the mass distribution is more, the reluctance to move is more. And when an object is moving, if the mass distribution is more, the reluctance to stop is also more, right? It doesn't want to stop when its mass distribution is high, right? Can understand? Can somewhat take a understanding? Yes. So sort of you know the moment of inertia. Now the Johan has come, right? Johan, hi. People were waiting for you and we had to start. Right. So moment of inertia, shall we start from here? Now moment of inertia, the measure of the inertia of an object in a rotational motion is its something is wrong here. The measurement of the inertia of an object in linear motion is mass. Can you correct it please? Can people correct this in the tute? Now Shiny, have you received the tutes? Where's the pen? Now this has to be corrected, right? The measure of the inertia of an object in linear motion is its mass. The moment of inertia of an object in rotational motion is a measure of its inertia. The moment of inertia of a particle of mass m about an axis r away from it is given by I equals mr square, because the inertia of a rotating object is depending on the mass and the radius together. Get it? It depends on the mass and the radius together. And what do you see here? The I is equal to mr square. So it's majorly depending on the mass or the radius. It's majorly depending on the mass or the radius. Bro, do you see that it's r square? Right? Though you double the mass, the inertia will double. But if you double the radius, it will become 4 times. Get it? So greater the radius, greater the inertia, right? Moment of inertia. So the moment of inertia is depending on the radius more than the mass. It depends on the mass as well, but more than the mass, the moment of inertia is depending on the radius. So what does that mean? What does that mean? So if you take something to rotate, something is this? Ah, yes, right. I'm gonna rotate it as like me put it. That won't happen, right? So like what does it mean? It means now if you are rotating this in a small circle, right? So this is the mass. So if you are rotating this in a small circle, it will be easy, right? Easy peasy. You can do it like with a ease, right? It's easy to rotate. Because why? The radius is less. So the mass will be same. This is the mass. So the mass hasn't changed. Now the radius is this, small radius. Just try doing it, come. Now I am increasing the radius. So increase the radius means like what happens to the inertia? Inertia increases. Do you get it? I equals mr square. So inertia increases means the reluctance to move is more. So does it move easy or it will be hard? So then now I increase the radius. Do you see it? I increase the radius. I had to rotate this for a circle. Would it be easy? It's actually not. For me, like it's easy, but you know, for the greater radius, it will be harder, like relatively. Like the small radius, it's easy, but when it comes to greater radius, it's really hard to take a rotation. It's hard to do a rotation. Now think of a mass with a very long distance. With a rope with a very long distance, can you like rotate it easily? Try doing it, right? You have to have the experience rotating something like that. With a long lengthy string and a mass attached to it, and you are trying to rotate it to a circle, it will be hard. But closer the string, closer the radius, it's easy to rotate because inertia is less. Get it? So more the inertia, the reluctance to move is high. Do you understand that? Right. So that is about inertia.
Move කරන්න radius එක වැඩි වෙනම දෙන්න ඕන force එක අඩු වෙන්නේ
නෑ. වැඩි. ඒකයි හිමින් කරේ. Ask the bro, the professional. This guy. That's true. හරිද? ඒ කියන්නේ radius එක වැඩි වෙනකොට අපි යා move කරන්න දෙන්න ඕන force එකත් වැඩි වෙනවා. Just think it like the mass in the linear motion. The greater the mass, the force that it takes to move is high. The same way, the moment of inertia is like the radius and the mass together. very very. So the greater the radius, it's really hard to rotate, right? So that's it. That is moment of inertia. Understood it? People online, do you understand it? Johan, please tell something. Ah. Yes sir, okay. Shiny understood. Nice, Johan. Johan says hi sir, bro. Tell me you understand it or not. Understood sir, okay. Nice. Okay, so moment of inertia of a solid object, right? So moment of inertia of a solid object is depending on the collective inertia of all and each particles in its mass. Do you get it? The collective inertia of the all and each particle masses of the object is its inertia of the object, right? So if I take this object, do you see the mass distribution here? M1 into M3 likewise, and there are like different radiuses. The inertia of this object will be the collective inertia of each and every particle masses in the object. Get it? Right. So the moment of inertia of a solid object, a rigid body can be considered as a system of particles. The moment of inertia of the body about a certain axis is the sum of the moments of inertia of each particle about that axis. Understood it? Understood it? Like in an object, the inertia of the object, like the moment of inertia of the object is the inertia, the moment of inertia of each and every particle masses. Get it? Collectively. That's what it says, right? So the moment of inertia depends on three things. What are the three things? First one is mass.
Radius or the distance.
Okay, the mass and the radius in the sense we call it distribution of the mass, and the next one is what? There's another thing. Axis. The axis. Huh? Axis in the sense like if I take this. Now if I rotate this object from the middle. Oh. Like the pivot point, place where the rotation occurs. Now if I rotate from here, the effort that I have to put to rotate this, and if I rotate it from here, if I take the pivot point from the edge, the effort that I have to take to rotate this will be different. Now which part has to have the greater, the force, and tell me which one has the greater moment of inertia, this or this? Make it moment of inertia. Ready? Why do you say it like that? The radius. Good. Right. Now you understand. Right. Nice. So the radius is more. That means the mass distribution is more. So more the mass distribution, more the moment of inertia, and harder to, to move it. Right. So this is easy. This will be really hard. So the moment of inertia of this will be less. This will be more. Understand? So depending on the axis and the object, like depending on the axis and its mass distribution, there will be different formulas for many of the other objects, right? We're going to discuss the few of the formulas, but in your exams they supposed to give the formula, so don't study it, right? So many of the formulas are there, so don't study it. It's supposed to be given in the exam for sure. Then you take a call in the moment. Yes. Right. So I have the number because that's one of my aunties. It's making the paper. So I have the number. I will give it to you. You tell everything you want, right? So what are the factors that affect the moment of inertia? First one is mass, right? Distribution of mass. Mass distribution. Like the greater the mass, let's say I'm taking the same radius, 1 kilogram of a mass. Then in the second time I'm taking the same radius but a 2 kilogram of a mass. Now what happens? Which one is harder to move? Second one, because the mass is more. in the other like in another time, I'm taking a radius of 1 meter and 1 kilogram mass, and I'm keeping the same mass but in a 2 meters of a radius. Now which one is reluctant to move? Same mass, but I made the radius twice the first one. Which one is hard to move? No. Greater the radius, greater the inertia. How come the radius? Now greater the radius, greater the inertia, moment of inertia. So that we discuss, like more the radius, it's really hard to take a circular motion. දෙපාරක් නෙමෙයි. These are two things. Mass කියන එක radius එක constant කියලා තියලා බලන්නකො. Same radius. One, now listen. Focus. So 1 meter of a radius. 1 kilogram of a mass. You are rotating it. Right? And again the same radius, but I'm increasing the mass. Right? So which one, like increasing the mass in the sense like I'm making it 2 kilograms. Now which one is harder to move? Second one, because mass increased, so the moment of inertia increased, right? In the second time, I'm taking a 1 kilogram of a mass and a 1 meter of a radius, right? And you're rotating it, and I'm giving in the second time of the like in that scene, I'm giving another one with the same mass, but I'm increasing the radius now to 2 meters. So which one is harder to move now? Second one, because the radius is high, so the moment of inertia is high. So the increased radius means mass distribution. The distributed mass, like the radius. The radius is the distribution mass. Yes. Mass distribution is that. Mass distribution is simply the radius actually. So we don't call it radius, we call it mass distribution. So it's actually the radius. So we call it mass distribution, right? කෝකද එක වගේ? ඔව් එක වගේ, but two different things. නේ? ඒ කියන්නේ axis එක වෙනස් වෙනකොට mass distribution එක වෙනස් වෙනවා. That's true. ඒ කියන්නේ ඒ දෙන්න integrated. That's true. But two things, right? Oh. No, like axis එක දැන් මේ එකම object එකේ axis එක වෙනස් වෙනකොට mass distribution එක වෙනස් වෙනවා. ඒ radius වෙනස් වෙනවනේ. දැන් මෙහෙම තියෙනකොට මෙතනින් ගත්තාම පස්සේ mass distribution එක තියෙන විදිහයි මෙතනින් ගත්තාම mass distribution එක තියෙන විදිහයි වෙනස්. Axis එක වෙනස් වෙනකොට අත්‍තරම mass distribution එක වෙනස් වෙන්නේ. But the mass distribution and the axis are two things, not the same thing. Right? They are interrelated. That's the only difference. Yes, those are interrelated things, right? They are interrelated. So the mass distribution, the final one is axis, right? Axis. So we are going to do a practical as well. Sir, මේ lesson එකේ equation එකක්වත් පාඩම් කරලා මතක තියාගන්න ඕනේ නේද? ඕන. ඒ කියන්නේ except for though එකක් එපා කිව්වහම කොහොම අතරින්ද දාද? Only the moment of inertia equations you don't have to remember because the people are supposed to give it and they will give it, right? Only the moment of inertia. Yes. ඉතුරු දෙන්නේ. ඉතුරු ඔක්කොම ටික මතක තියාගන්න ඕන. And I think this is the lesson with the more like the most of the equations, right? මේක තමයි වැඩිපුරම තියෙන්නේ. Examine depends on the ස්කූල් එක තමයි region එකක් ඔයක apply කරනකොට දාන්න තියෙනවනේ. ඔයාට region එකක් කොහෙද දාන්නේ? ස්කූල් එක select කරන්න තියෙනව නේද? ස්කූල් select කරන්න. ඒ region එකේ ඔයාගේ address එකට ළඟ close proximity එක තමයි select වෙන්නේ. Not side ado.
No.
Because it's a boys' school. Yes. Huh? Ananda Balika වගේ. Something like that. සයිඩ දැම්මුත් කොහොමවත් උන් විභාගෙ ලියන්නෙත් නැහැ ඊට පස්සේ. වෙනුම් පරණක් වෙනවා. Oh, we made a video. So people are texting me and asking if they can come to the class. I said no. So not allowed, no. None is allowed. ගිහිල්ලා තිබ්බ එක. ඒ කියන්නේ ඔව්. රීච් එකක් තිබ්බා. Why? Oh, yeah. You didn't see it now, ne? I Penujage video. I made a video of it. You didn't see it? අර බෙන්ඩ් එකක් ගන්න එකේ අපි අර කතා කරේ රියැක්ෂන් එක ගන්න එක සීට් එකේ ඉන්න එක නේ. I was explaining it to you. Ayash is online. Hello, Pute.
Hello?
Hello, Ayash.
Oh, Ayash, Amma.
Oh, Amma, we are in the class.
Sir,
Are you in a hurry?
Oh.
Hadisiyad?
No, sir, no.
sir. Oh, I will take later.
Oh.
Okay,
Okay, thank you.
Okay. I thought me online mark karge se kila Ayash India ne kali. Right. So come to this part. Video එකක් දාලා තිනවා මේ ඔයාගෙන බලන්න ගිහිල්ලා. තාම දන්නේ නැහැ. කමෙන්ට් එකකුත් දාන්න. Facebook and Insta. I will send it. හරි. අර ඉස්සර වගේ ඊමේල් එකක් දාලා කෝල් කරලා කියන්න ඕන බලන්න. Right. Moment of inertia difference of different objects, right? The moment of inertia also varies depending on the shape of the rigid object. Using the above general relations have been obtained for the moment of inertia of rigid objects of various shapes, right? මේවට අරගෙන තියෙන වෙනම equations. Some of them are shown below, right? So these are the objects so far. So this is shall we write these things? මේක මොකක්ද එන්නේ? Rod එකක not from the middle, from the end of the like axis, from the end. අපි එක ලියමු. Right. Make a under what do you call it? A rod, right? Yeah, thin rod. At the end point. Thin rod at the end point. Rotating from the end point. You can pivot point again. Pivot point again, end point again. Yeah. This one again a thin rod. Yeah, rotating from the midpoint. Thin rod rotating from the midpoint. That's marketing. Bro, marketing really. I was making other video. This is marketing. I'm making it for fun. Yes. ඊළඟට යහන දා මාකට් කරන්න. ඔව් ස්ලැප් එකට. යහන ඊළඟට කැමරා ඉස්සරහට ගෙනලා මාකට් කරනවා. Midpoint. This one is midpoint. See. Now do you see the difference? Now the end point is 1/3, right? And the midpoint is 1/12, right? Which one is greater? End point is greater because the mass distribution is more, right? Right. So the other thing, this is a hollow circular disc. Hollow circular disc rotating from the midpoint. Hollow disc rotating from the midpoint, or the axis is from the how do you say? I have to say they usually they don't say the point. Like if it is a object, usually the symmetrical axis will be the axis. Now the symmetrical axis most of the time goes from the mid, like that. So the next one, a hollow cylinder. Hollow cylinder. Rotating from the mid axis. Rotating from the mid axis. Yep, rotating from the mid axis. Oh. Inertia එක මෙයාගේ වැඩි, inertia එක මෙයාගේ අඩුයි. මෙයාගේ 12 වලින් divide වෙනවා, මෙයාගේ 3 වලින් divide වෙනවා. 12 වලින් divide වුණොත් inertia ගොඩාක් අඩු වෙනවා division එක.
එතකොට mass එක කියන්නේ 12 වලින් මේ වුණාම mass distribution එක වැඩි.
12 වලින් බෙදෙනකොට අඩු වෙනවා. අඩුයි. mass distribution එක අඩුයි. Right. The next one is a solid disk. ඒක repeat වෙලා එකක් cancel out කරගන්නවද? Same thing. Solid disk. So all the symmetrical objects have like the mid axis. So don't have to mention it. Next one is a solid cylinder. Solid cylinder. This one is a solid sphere. Solid sphere. This one is a hollow sphere, right? This one is a hollow sphere, right? This part is a hollow sphere. Get it? කොකේද ඉනර්ෂියා එක අඩු? මොකේද? මේක ඉනර්ෂියා එක ඕකේ වැඩි නේ අරකට වඩා. මේකට වඩා? ඕක අඩුයි යට එක වැඩි. ඔව්. ඇයි? ඉතින් මෙයාගේ complete mass එකම තියෙන්නේ කොහෙද? circumference එකේ. mass distribution එක වැඩි. මෙයාගේ මේ තියෙන මුළු mass එකම මෙයාගේ circumference එකේ තියෙන්නේ. ඒකද මෙයාගේ වැඩි වෙන්නේ ඕක. Oh, you're a genius, yeah. Huh? Understood it? Okay. Right. Done? මේ ටික දාන්න පුළුවන් නේ m කියන්නේ mass එක. මේ තින්නේ l කියන්නේ length from the pivot point. හරි. pivot point එකේ ඉඳන් තියෙන length එක තියෙන්නේ. Right. So calculate the moment of inertia about each point of system below. Now the xy distance is equal to 2 meters. x එකයි y එකයි z එකයි වෙන වෙනම axis තුනේදී moment of inertia හොයන්න the equations were given in the table. If the online people want to see it back again, put a text in the inbox. And for the people who are joining online, so there will be an issue coming. I'm not saying it's an issue. So from the next month, for the people who are joining online, apart from the people who already are joining the physical class, without the subscription, you know, like the doing the payment, so they won't allow the link, because they won't send the link for the people who haven't paid the, you know, the monthly payments. And I have uploaded the videos to the YouTube, and I'll have to take, not to take down, I'll have to put all them into private. And if we have any sort of trouble, you know, when it comes to the money or any of the other things, just put a text, like discuss it with me and the institute, take the decisions, because we have to go in a, you know, scheduled manner, that because මේ ඔක්කොටම මේ setups වලට මේගොල්ලෝ cost එකක් දානවනේ. එතකොට ඒ cost එක ඒගොල්ලෝ recover කරන්න ඕන. ඒ හින්දා අර මම YouTube දාන ඒවත් දැන් මට private දාලා තමයි තියන්න වෙන්නේ, because මේ වෙනම system එකකින් ඒක upgrade වෙලා යන හින්දා. So if you have any issues with the money or something, if you can't pay the you know, the monthly payment, for the people who don't pay, just put me a text, so I'll ease on them. I'll do something for them. Private දාන්න වෙනවා. But you people give me your email, so I'll මට දෙන්න මම ඕගොල්ලන්ට access දෙනවා. Physical එන ළමයින්ට මම ඔක්කොටම access දෙනවා. ඊට පස්සේ online payment කරන ළමයින්ටත් ඒගොල්ලන්ට access දෙනවා. ඒ කියන්නේ online payments කරන අයට මගෙන් නෙමෙයි access එන්නේ. මෙහි. ඔව් ඒගොල්ලන්ගේ මේ එක හරහා තමයි හම්බෙන්නේ. app එක හරහා app එක තුල තමයි හම්බෙන්නේ. නේ? App එකකින් app එකකින් දාන්න. Done, finish. Got the values? No? Why? Still thinking. Bro, the equations up there. If you are taking from the endpoints, that will be 1/3 of mr square. So the r is given 2 meters. If you are taking from the x, this is the x. Now tell me, if you are taking it from the x, would the 5 kilogram mass affect or not? No. We discussed this under the moment, right? Moment. We discussed this under the moment, because the force which is applying in the pivot point, on the pivot point, is not affecting the rotation. Why? Because it doesn't have a distance. Simple. So you don't have to worry about the mass on the axis, right? It doesn't affect the rotation or the inertia, because to inertia to occur it has to have a radius. So my lesson equation it's the same like all message here. You can't put a message. Who else are there? Like I can't see many. Johan Isuke is there, Dishmita, Kishara, Uvindu, Sadesh, Shiny is there. Few of the new people are there, Dishmita, Kishara, Uvindu, Sadesh. And I can't see the rest of the people because of cover velati. And many others are there. So who ape mea hathine the Yuhasa? Yes, are you there? Are you with us? Yes, are the injured? Yes, are you cricket gala? Oh, the Livanala, Kumagala, she's dead. Yes, yes, is there. Done? Z axis again and full axis. A axis එකකින් නම් මෙහෙට තියෙන රේඩියස් එකයි මෑස් එකයි මෙහෙට තියෙන රේඩියස් එකයි මෑස් එකයි අර ඉනර්ෂියා දෙකකට අරගෙන ඇඩ් කරන්න ඕන. නැත්තම් එක ඇක්සිස් එකකට ගන්න. දෙකම එකයි. will be same. Give the same answer. අර couple of forces වලදී අපි ගත්තේ මතකද? අන්න ඒ විදිහට ගන්න. Now can they see me if I... Yeah, because we are going to do a practical here. Core me. Nice. Pena මගේ උඩ හරිය පේනවා මේ මේක පේන්නේ නැහැ. ඒ කියන්නේ පුටුව පේන්නේ. මන්ත්‍ර බලෙන් උඩ ඉන්නවා වගේ තමයි පේන්නේ. රොටේට් වෙනකොට නේ. ස්පිරිචුවල් පවර් එකකින් ඉන්නවා වගේ තමයි පේන්නේ. ඩම්බෙල් එක ගින් දෙන්නත් ඕන. Done? Finish? Yeah. Either you take it from the middle. So if you, anyways you have to take the axis from the middle. When you're taking it from the middle, either you take the inertia towards this mass, inertia towards this mass, and at the two of the inertias. එහෙම ගන්න පුළුවන් නේ. මේකට mr² දැම්මා, මේකට mr² දැම්මා, ඇඩ් කරා. ඇක්සිස් එකේ නේ.
එතකොට 112 නේ ගන්න ඕන මිඩල් පොයින්ට් එක නිසා නේ.
මිඩල් පොයින්ට් එකේ 112 තියෙන්නේ. ආ. ඒක 2 of the 112s දාලා ඇඩ් කරලා ගන්නත් පුළුවන්.
ඒකේ 112 දාලා ඒකේ 2 of
ඒ කියන්නේ මෙතන ඉඳන් මේක 1 meter distance. එතකොට 112th mass 2 kilogram r එක 1 square. Right? r කියන radius නේ 1 meter නේ. මේක 2 නම් මේක 1 නේ. එතකොට 112th mass 2 kilogram 1 square plus මෙයාව ගන්න.
equation දෙකක්
දාලා add කරනවා. Because they are rotating in the same direction නේ. Same direction එකට යනකොට inertia එකම පැත්තට add කරලා ගන්න පුළුවන්. Or else think of this as a couple of forces. Like what do we do in the couple of forces? We take the two of the forces and you multiply it by the distance in between. You can do the same, you know. So you take 1 over 12, you add 2 of the masses, which is now here 7, and take the complete diameter or the complete distance between 2 of the masses.
that's 2 right.
Yeah, that's true. 2 square will give the same answer.
That's okay.
Just check if you want like two of the ways will give the same answer. So if you're taking it from the middle, you can like do the the calculation in like in the couple of forces, right? Shall we discuss it? So calculate the moment of inertia above each point of the system below, right? So the distance here is how much? 2 meters, isn't it? It's 2 meters. So first axis is to take from the x point. So now it's from one of the ends, right? So if it is from one of the ends, the equation will be 1/3, is it? Yeah, 1/3 mr square. So the equation will be 1/3 mr square, right? So 1/3. Now if I am taking this axis, this 5 kilogram mass doesn't have to do anything with the inertia because it's in the pivot point or the rotating point, so it doesn't affect, right? So the only mass that is distributed is 2 kilograms, so that is the only mass which is affecting. So 2 kilogram and the radius square. Now the radius is 2 and it's square, right? So that will be 4. So how much? 4 into 2 is 8. 8 over 3 is how much? 2.66. And the units will be kg m square, kilogram meter square, right? 2.66. So dumbbell එක පොඩ්ඩක් පෙන්නන්න. How do you know there's a dumbbell? Oh, how does he know? That is for the practical. අපි තව චුට්ටකින් practical එකක් කරනවා. ඔව්. මේ ගෙදර weights ගහන. නෑ ඔව් මේක 2.5 එක. මේක gym එකෙන් එන. කාගාව? යන් 10 දෙකක් තියන මොනවද දන්නේ කරන්නේ? 10 දෙකක් තියගෙන මේක තියන බත් කනවද කොහෙද? අඩු වෙලා නැහැ නේද? Well, that's small. Yeah, that's small. That's okay. That's for the practical. I'm not doing it. No, I'm doing like I don't do much of the bicep. I do triceps most of the time, and I lift like 50. Yeah, for the tricep sometimes 50. මේක පොඩ්ඩක් ගිහිල්ලා තියෙන ලාවට තියෙනවා. මාකටිං මම මේක බලලා ඉවහන් තමයි එන්නේ. Right, and yeah, gym body. Right. Then the next one, y equals like from the y-axis. So if you are going to take the this axis. So if you are taking this axis, that means 2 kilogram doesn't affect because it doesn't have any distance. So, but it will be from the one of the ends. So the equation will be 1/3 mr square, right? So 1/3 mass will be then 5 kilograms, right? And the radius will be 2 square. So 2 square will be 4. 4 into 5 will be 20. 20 over 3 will be how much? 6.66 kgm square. So what happened in these two, the axes? The distance was equal, wasn't it? 2 meters, but the mass changed. So greater the mass, greater the inertia. That is what is there to take, right? And the third one is from the z axis, which is from the middle. Now there's two ways you can calculate this one, right? One is you can take two of the masses to either sides and take it like two different distances, and two different masses have like two different inertias. You take the two of the inertias, add together, you get the answer. Or else take it as a couple of forces. How do you take the couple of forces? You take the two of the forces together. Yeah, and the perpendicular distance between each other will give the same answer, right?
0.0 අඩියක් වෙනවා.
A because of the decimals. So if you take the
හරි ඒක
Harid, so it will be 1/12, right? 1/12 mr square. So මෙහෙම ගත්තොතින් 1/12 දැන් mass එක ගන්න වෙන්නේ 2 of the masses together. 5 plus 2 will be 7. And the r will be 2 meters. Distance between the two of the masses, so that's 2 square. So that will be 4 into 7 is 28. 28 over 12. Here cannot. 2.33 kgm square. Or else අපි අර කතා කරපු විදිහට චුට්ටක් ඩිස්කස් කරමු. ඔව් ඒ කියන්නේ මේ දෙක වෙන වෙනම ගන්නවා. ඒ කියන්නේ මෙතන ඉඳන් ගත්තොතින් මෙයාගේ ගන්න වෙන්නේ අර එජ් එකේ තියෙන විදිහටනේ. මෙතන pivot point එක මෙයා එජ් එකේ ඉන්නේ. එතකොට 1/3 mass is 2 kilogram and the radius is 1 square plus මෙන්න මෙතන ඉඳන් අපි ගත්තේ දැන් මෙතන ඉඳන් මේ පැත්තේ mass එක. Now we have to take from the axis, this is the distribution of mass.
point එක වෙන්නේ 5 kg තියෙනවා.
ඔව් end point එක තමයි 5 kg. මේක තමයි මේ pivot point එක axis එක. So 1/3 that will be 5 kilogram and the distance is 1. We'll give the same answer, right? So you can take the 1/3 out. That will be 1 square is 1. No, so 2 plus how much? 5. So that will be 7/3. 7/3 will be මේක
2.33.
ඔව් මේක දෙන්නම 4ෙන් මල්ටිප්ලයි කරාම පස්සේ 7 4ෙන් මල්ටිප්ලයි කරාම 28 3 4ෙන් මල්ටිප්ලයි කරාම 12. So it's same. We'll give the same value 2.33 kg m square. You can simplify it in both the ways, doesn't matter.
So ගන්නේ C එකක් වගේ ගන්නවා example එකකට.
Eh?
C එකක් වගේ දාන්නේ example එකකට.
මොකක් දාලා?
ඒ කියන්නේ C එක දාලා ගන්න තියෙන්නේ rotating point එක. ඒකට දාලා
values දාලාද?
පොඩි example එකක් දෙන්න.
I mean, you people done with this? You right? Done? Even the online people? Process is too small. මේක බලමු. එතකොට අපි හිතමු මෙයාගේ ගන්න වෙන්නේ එතකොට complete mass එක හොඳේ. complete mass එක. complete mass එක අපි හිතමු 5 kilograms කියලා. එතකොට එන්නේ 2/5 5 kilogram.
එතකොට බෝඩි නිකන් එහෙම තියලා කරගෙන යන්නද ගන්නේ?
ඔව්. complete mass එකම කරකිනවා.
කරගෙන.
ඒ කියන්නේ complete mass distribution එකම consider කරලානේ අරගෙන තියෙන්නේ.
එතකොට ඒක මුළු බෝඩිම මේ
distribute වෙලා තින්නේ 5 kilogram එක.
ආතර ඒක හොලෝ නම් 180
විතරයි. ඒකයි මේක 2/5 2/3 කියලා වෙලා තින්නේ ඒකයි. difference එක ඒකයි. මේකේ value එක වැඩි වෙලා තින්නේ ඒකයි. අර margin එකේ නැති mass එක. length එක වැඩි. එතකොට distribution එක වැඩි. So the radius we take it as 1. Easy. So what will happen? Yeah. 2 kg m square. No difference. Right. මේකෙත් එහෙම තමයි. mass එක එතකොට edge එකේ තියෙන mass එක තමයි එන්නේ. අපිට mass එක විදිහට දෙන්නේ mass එකම තමයි. වෙනම එක වෙනස් වෙන්නේ. Right. Done. Nice. Okay. Right. Come to the next part. Newton's second law of motion states that the rate of change of momentum in the direction of the force is proportional to the force. Can you remember that? Rate of change of, can you remember that? The Newton's which law is this? Newton's second law, right? The rate of change of momentum in the direction of force is proportional to the, yes. So the rate of change of momentum is equal to the force. Yeah, F equals mv minus mu over t equation. This came under the force. Can you remember? There was the equation like that. F equals mv minus mu over t, right? So there's an equation like that. That is the Newton's second law, and it's the equation, right? So mv minus mu over t. Accordingly, the equation obtained is F equals ma. So we derived F equals ma from the equation F equals mv minus mu over t. Can you remember that? Now this is how it happened. That's it. So there's this equation. If firstly it was proportional, F is proportional to the mv minus mu. What do you call mv? Final momentum, and the mu is initial momentum. You divide it by time, what do you get? The rate of change of momentum is proportional to the force. And he had to do some experiment to find what is the relationship between the values here and the F, and he found it's exactly same. So he made an equation F equals mv. Oh, constant එක එකයි. That's why. Oh, whenever we change වෙනවා. ඒ හින්දා constant එක stays with the formula. But in this case, constant becomes 1. So constant doesn't have to stay. අනිත් ඒවාකදී ගන්න constant එක ඒකම තියෙනවා. If you can remember it. In these cases, what we do is we take a proportion to make the proportion, or to convert the proportion into an equation. You have to put a constant there, right? And the constant makes the two of the proportions equal, right? So in this case, there is a proportion which is 1. So you multiply anything by 1, it becomes the same. So you don't have to use it, right? So that happened there. So bit of a science is there, yes. It's very important name. So since you asked, I replied, right? So mv minus mu over t is the equation, because the constant is 1. F equals mu minus mu over t. So you take out the mass m, you will get an equation v minus u over t. Do you see something here? V minus u over t. That is one of the, the equation for the acceleration, because v equals u plus at was there. We wrote it back in the table, yes. So you isolate a, what do you get? V minus u over t is equal to a. So simply v minus u over t is a. So F equals what? ma. That is how you derive F equals ma from this equation. Get it? So we discussed under the force. If you can't remember it, you go to the recordings, force, go through it, it's there, right? So the other thing is, like, people should do, so hit a force seminar එක තියනවාද SASIP එකේ? No. That's the issue, because I wanted to do the force seminar here, Vice Path, because we can have a recording, so you can watch it back, because we'll be doing the calculations. So it's a good thing if you have the recordings, right? Otherwise, only the people from SASIP will get it, the other people won't. So I want to do it here because of the recording, right? And I'm planning it to have it here, but on Wednesday the schedules are busy. So I had to like shift it to another day. So the tomorrow is free, but all of a sudden, no, not tomorrow, the day after tomorrow is free, but all of a sudden we can't plan to have all the people here on Thursday. So most probably it will be on next Thursday, the seminar here in the morning. So next Thursday here in the morning there will be a seminar, and I'll put something, I'll put a note on that. So join. You should. It's a must, yes, because we'll be. Come physical, like, if you can, like, you are staying nearby, you come physical, bro. Yes. So like come to the class, and even the online people, you just join people, and cover the questions. Go through the questions. That's the first thing. You have to go through the questions first before I'm doing it. And in the seminar, I'll be discussing it, so you will understand it. If you struggled really well, you should struggle really well. No? You should struggle with the questions. So once you struggled is finished, I'll start like explaining it and doing it by myself. So you'll understand like crystal pure, right? So that's what happens. Like that's what should happen. Otherwise, you'll get nothing. Usually, if you're like board එකේ කරන්න මොනවද කියලා බලන් ඉදියට ඔයාට මුකුත් තේරෙනවා. ඊට පස්සේ නෑ මුකුත් නෑ. That is a science. That's not a big thing. It's a science. I told you in the morning, right? It's a science. ඒක තමයි. You have to go ආපහු බලන්න. You have to check it. Right. Okay, so thank you. That's your thought. Right. So accordingly, the equation is obtained is F equals ma. Similarly, in the rotational motion, when an external force is applied, the angular momentum changes. The rate of change of angular momentum is proportional to the external force. Accordingly, the equation obtained is what? Tau equals, now the F is, the F is force, no? So the F is torque. In the circular motion, F is torque. They are more alike, not the same but alike, right? So instead of yes, mass is inertia. So tau, like the F equals ma, and the tau equals I alpha, because I is something like the mass in the linear motion. It's a mass distribution. කොතනද? මේකද? මේ පාට කියු. හරිද? tau equals I alpha, right? And tau is what? Tau is there's another equation for the tau. Tau is what? Tau is moment back again, isn't it? Moment, isn't it? Newton. Yes. So tau is again the moment, isn't it? Tau is again the moment. So moment is what? F into d. Or in circular motion, we'll take the d as r, because it's moving in a radius when it's circulating, isn't it? So tau equals, if r is another equation, in this case r is what? අපි ඒක capital R ගමුනේ. Shall we? In this case r is what? Radius. මේ ටික define කරගන්න. Tau is කොහොමද? That will be too much, because too much of information makes too much of a confusion. So don't. Just remember these ones and type of the questions that will come, I'll give. Go through them. Type of the questions that will come, I'll give it. Go through them. Enough. Because if you want to go deeper, like there's lot of superb theories are there, like beautiful theories are, now for real. Beautiful theories are there. More you go deeper, more you understand. You can do it when you go to the university. Then tau is what? Oh, you are doing IT and then no, you don't. Right. You don't like it anyway. Okay. Like durian. Okay. So torque is the tau is torque. This is torque. TRO QUE, torque. Something happened. Torque. I is what? Inertia. It's moment of inertia. Right. Difference is there. Moment of inertia. Alpha is angular acceleration. Good. Here the force, F is force, R is radius. People online, do you understand it? Johan, do you understand it? This is torque. This is moment of inertia. Understood. Nice. Yuhasa, Shiny, Sadesh, Kishara, all the people online. This is moment of inertia. This is angular acceleration. This is force. This is radius. Huh? What happened? Oh. මම තනම එක එක ඒවා ගහලා විම් බෝම්බ හයි කළා වගේ. හරිද? Done? Nice. So do you understand this? This is more like the F equals ma, because when you give a torque, the moment of inertia is accelerating. Simply that's what happens. When you give a force to a mass, mass is accelerating, isn't it? When you give a force to a mass, an object, the mass is accelerating, isn't it? It's accelerating. When you give a force, let's say this is an object, you hit a kick, so it will start accelerating in a linear direction. But in the circular motion, it happens with a torque, not with a force. The distance matters, right? Force and the displacement. So give a torque, the moment of inertia is starting to accelerate. Get it? You have to think of a bit, because it's not like none of the usual thing that happens in your life. Moment of inertia doesn't happen in your life, does it?
Angular acceleration එක ගන්න අර මේ නිකන් normal acceleration එක ගත්තොත් ඒක linear තියෙන හින්දා යා angular acceleration එක ගන්න ඒක angular wise acceleration.
Oh, like me, two different scenarios, linear and circular. So they have two different, like the different, the things to define. මේවා වෙන වෙන මේවා තියෙන ඒගොල්ලන්ගේ තියෙන ඒවා. So different things, right? But they act like same, like in the sense of like how they works are more like same, but they are likely not same, like they are alike. They like when you give a force, it will move in a linear acceleration, like will be a linear motion. When you give a torque, it will be moving in the circular motion. Like two of the motions are there. The linear motion happens because of the force, circular motion happens because of the torque, right? So they are alike, but not same, because circular motion is a different motion, linear motion is another motion. So for the linear motion, the mass effects, which is we call the inertia. But for the circular motion, not only the mass, but the mass distribution, which is moment of inertia effects that we discussed. Greater the length of the string, harder to rotate, which means that you have to give a greater torque. If the length is too much, you have to give a greater torque to rotate, and to make it accelerate, right? So these are not the things that you usually see, or that you usually sense. Moment of inertia, you don't usually sense it. No, the issue is actually you don't know it, so you don't see it that way, right? But when you know it, you have to see it that way. It's the same thing like we discussed the last week, the centripetal force. You were there in a bus when the bus is taking a bend, right? But you never thought of the centripetal force, no? Because you didn't know it. Hari, you are not Isaac Newton, I know that. My point is, these things are not the usual things for you. I know that. But when you know, because you didn't know it before. But when you know it, you have to think it that way so that you will understand. Otherwise you won't, right? When you understood it, when you learn it, you have to try seeing these theories outside the world. You see it? You have to do it. Why not? Then bus you have to take the reaction force, the centripetal force, otherwise Oh, I cannot try. So those theories, in you know, the some parts you have to try to understand it in the real case. What happens there, right? Slap pick. You try the slap. Okay. Mamad, I have seen it. That is why I told you. Huh? Yeah, there is one of the Indian pranking video. These people are pranking someone, and අර මොකක් හරි හෝන් එකක් අරගෙන ගහනවා හයියෙන්. That guy doesn't even move me cell. He stays rigid. හරිද? අර හයියෙන් බස් හෝන් එකක් වගේ ළඟට ඇවිල්ලා ගහනවා. move වෙන්නේවත් නැහැ. ඊට පස්සේ හැදලා එනවා මෙහෙම. මෙහෙම කරලා මෙහෙම ගහනවා. සටාස් ගාලා ගහනවා. නෑ අයියෝ බ්‍රෝ. ඒ කියන්නේ අර ප්‍රෑන්කර්ස්ලා වගේ එකක් ඇවිල්ලා අර හෝන් එකක් ගහනවා මේ මිනිස්සෙට. සාමාන්‍යයෙන් අනිත් මිනිස්සු බය වෙනවා. This guy doesn't even move. ඊට පස්සේ මෙහෙම හැරලා බලනවා. He comes and කරකවල ගහනවා. ඒ පාර වදිනවා නිකන් ආයි හොඳ පාරක් වදිනවා. So that's a circular motion. අර ලීනිය එක වෙනකොට යා සර්කියුලර් ගන්න. එනර්ජි එක වැඩි. එහෙම ගහලා බලන්න ඕන ඇත්තටම එනර්ජි එක වැඩි. මෙහෙම ගහනට වඩා වැඩි. කරකොල ගහමු සෑහෙන එනර්ජි එක තියෙනවා. දුෂාන්ත ගහලා බලන්න ඕන ආයෙ මොනාරි ආගෙන ආවදී. කිල්ම ගන්න. හුලං එන්න ගන්නවා. Right? So do you understand this part now? I know that you won't understand අර ලොකු image එක එකපාර බෑ තමයි. හරිද? But we'll go through the questions, and when we discuss the question you will eventually understand, right? And මේකේ අනිත් එක theories මම discuss කරනවා. හැබැයි මම discuss කරන level එකටම questions එන්නේ නෑ. You go through the past papers. I will give, I think I already give you, right? I already gave the past paper classification, so go through the questions, you will see. ඔයා කලින් පන්ති එන්න ඕන දෙන්නේ මගේ දිහා දෙනවා I'll give it. Right? Come to the centripetal acceleration, right? Centripetal acceleration. So there's a centripetal acceleration, right? That means like that we discussed earlier. There's a centripetal force. නේ centripetal force එකක් තියෙනවනේ. ඔව්. force එකක් තියෙනවා නම් අනිවාර්යෙන් acceleration එකක් තියෙන්න ඕන. So we have to calculate the centripetal acceleration, the acceleration toward the center, right? So there's a formula for that. You have to remember it. The acceleration toward the center, if I take it as a, because it's one of the linear accelerations only, because force එකක් තියෙන්නේ හැමතිස්සෙම linear විදියට center එකට. ඒ force එකකින් එන yes. Oh, acceleration එක ඉතුරු වෙනවා. අපි එක කෙලින්ම ගමු. So this centripetal acceleration equals to v square over r, and the r is the radius, right? What is AC? ඒ කියන්නේ centripetal කියන එක තමයි c කියලා කියන්නේ. AC, centripetal acceleration is equal to v square over r. Right? And you have to know this as well. Now this is what? Tangential velocity, right? This is tangential velocity. So tangential velocity in another equation, tangential velocity equals v equals r omega, right? V equals r omega. So instead of v, what if we put r omega? It will be something like this. AC equals v equals r omega. So r omega and the complete square of it over r. Now this will be the same r, radius r. Oh, so AC equals, this will be r square omega square over r. Now what happens to the r? R will cancel out. So AC, yes, r omega square. This is another equation, like it's the same equation. gives the same value of the centripetal force. AC equals V square over R, or AC equals R omega square can be used. Right? No. But you have to remember it because මේකේ තියෙන equations ගන්න නම් ටිකක් කොහොමත් වැඩි. Number of equations are like so කන්දක් පල්ලෙහාට roll වෙලා යන එක ගන්න බැයිද? මොකටද? කන්දක් පල්ලෙහාට roll වෙන එක අපි discuss කරපු එකට අදාළ වෙනවද දැන්? මොකටද? කන්දක් පල්ලෙහාට roll වෙන එක ගන්න උනා. Yes. කන්දක් පල්ලෙහාට roll වෙලා යන එක ගන්න බැරිද? What do you mean? Yarn having like ගෙදර ඉන්නකොට මම හිතන්නේ එකපාරට අදහස් වෙනවා. මෙහි ඉන්නකොට සද්දවත් කරන්නේ නැහැ නේද? මොකේද පුතේ අහන්නේ මට? ඒ කියන්නේ අපිට මේ සිටුේෂන් එක පැහැදිලි. මොකද්ද තියරි එක ගැන අහන්නේ? Real text. Right? Understood it?
Yes, sir.
This one, this two. So you just only have to remember the equation for now. Just remember the equations, right? And can you define the terms? AC is centripetal, acceleration, centripetal acceleration. V is tangential velocity, right? Centripetal acceleration. Oh. Yes. මේකේ තියෙන පොඩි ලස්සන සීන් එකක් තියෙනවා මම කියන්න. Right. Bro, can remember something. Tangential velocity. අර tangent එක පැත්තට තියෙන velocity එක tangential velocity. ඉස්සෙල්ලා කතා කළේ circular motion එකකදී torque එකක් දෙද්දි acceleration එකක් වෙනවා කිව්වේ. ඔව් කන්දක් පල්ලෙහාට පෙළෙන එක ගන්න පුළුවන්. ඒ කියන්නේ කන්දක් පල්ලෙහාකදී නම් force එක විදියට ඒ කියන්නේ torque එකට force එකයි distance එක දෙකම ඕනනේ. දැන් you done with this? දැන් ඒක පොඩ්ඩක් ඒ කියන්නේ දැන් කන්දක පල්ලෙහාට පෙළෙනවා නම් හිතන්න මේ තියෙන කන්ද කියලා. ඒතර කන්දක පල්ලෙහාට පෙළෙනවා නම් මෙහෙමනේ කොටයක් කියලා හිතන්නකෝ. මේක පෙල්ලෙද්දි මේකේ circular motion එකට එකක් එනවනේ radius එක මෙයාගේ. එයාගේ radius එක එනවා. ඊට පස්සේ force එක එන්නේ මෙයාගේ මොකෙන්ද? මෙයාගේ rotation force එක එනවා මේ පැත්තට තියෙන friction එකේ. friction එකෙන් තමයි දෙන්නේ. එතකොට මෙන්න මේ forces මේ force එකයි මෙන්න මේ radius එකේ multiplication එක තමයි එතන torque එක. ඒක තමයි torque එක. මේ friction එකේ radius එකේ multiplication එක තමයි torque එක වෙන්නේ. හරිද? ඒක ඒ විදිහට calculate කරන්න පුළුවන්. නැත්නම් මේකේ moment of inertia අරගෙන දැන් මේක මොකක් වගේද? solid cylinder. මේක solid cylinder ගන්න කොටයක්නේ. solid cylinder එකක් නම් inertia එක හොයාගෙන මේකේ මේකේ inertia එක හොයාගෙන acceleration එකත් හොයා ගන්න ඕන. angular acceleration එක හොයාගෙන inertia එකකින් angular acceleration එක multiply කරාන් පස්සේ torque එක දෙනවා. එහෙම ගන්නත් පුළුවන්. different. ඔව්. ඔව්. ඒ කියන්නේ මෙයා roll වෙන්නේ friction එකකින් හින්දා. rolling effect එක කියන්නේ friction. අපි ඊතර circular motion එකට ගන්නේ roll වෙන force එකනේ. එතකොට මෙහෙම rotate වෙන්නේ. එතකොට slide වෙලා ඉන්නේ මොකෙන්ද? ඔව් gravity එකකිනුත් නෙමෙයි. මෙයාගේ එතකොට component එකකින්. මේකට තියෙන gravity එක මේ පැත්තට තියෙන gravity එකේ component එක. එයාගෙන් තමයි. අපි අර මේ breaking into components කියලා කරන්නේ. එතන මේ පැත්තේ angle එක තියෙනවා නම් මේ පැත්තට එන්නේ mg cos theta. ඒකෙන් තමයි එයා පල්ලෙහාට ස්ලයිඩ් වෙලා එන්නේ mg cos theta. හරි? right, something like that. හරි නේද යහන්? right. So come to this one. එතකොට v කියන්නේ මොකද්ද? tangential velocity නේද? tangential velocity. ඊට පස්සේ r එක radius omega කියන්නේ angular velocity.
අපිට මේකේ alpha ගන්න මේ මොකක්ද දෙන්න ඕනේ velocity change එකක්
දෙන්න ඕන. ඔව්. alpha හොයන්න. එතකොට ඔයාලට velocity change එකක් time එකක් දෙන්න ඕන. එතකොට ඒකෙන් alpha ගන්න පුළුවන්. මේකේ තියෙන questions එක different විදියට එතකොට ගන්න වෙනවා. හරිද? right. Shall we come to next part? right. ඊළඟ centripetal force එක. To show this, let us consider an object of mass m moving in a horizontal circular path of radius r at constant speed. Let us assume that the object moves from A to B at a time of delta t. මෙන්න මේ A වල ඉඳන් B වලට time of delta t වලදී ආ move වෙනවා කියලා ගන්න කියලා කියන්නේ. At a time delta t at subtended at an angle of delta theta above the center. එතකොට subtended angle එක delta theta. Although the speed is constant during the time, the velocity appears to have change in direction. ඒ කියන්නේ velocity එක constant වුණාට මෙයාගේ direction එක මොකද වෙන්නේ? change වෙනවා. ඒ change වෙන්නේ ඇයි? Because there is a force. If an object is changing its direction, it has to have a force. That is one of the features of a force, right? Force එකකින් අපිට direction එක වෙනස් කරන්න පුළුවන්. Right. The velocity difference is the velocity at B minus the velocity at A. Since the velocity triangle is constructed as in figure 2 above, the velocity difference is obtained by xy of the xyz triangle. Since delta theta is a small angle, velocity difference is v delta theta, right? So the velocity difference is v delta theta. Those are just bit of the information about how it happened, right? Doesn't have to worry much about. I have put it as a theory, right? ඒක එච්චරම worry වෙන්න එපා. That is how the theory is. Come to the centripetal force, right? Now before that, centripetal acceleration we discussed, right? What is the centripetal acceleration? The acceleration toward the center. The acceleration toward the center is always there in the object moving in the circular motion, right? And the person should be somewhat gaining that acceleration or the gaining that centripetal force. අපි අර කතා කරේ bend එකක් ගන්නකොට එයා reaction එක විදියට ගන්න ඕන. අර මේ වාහනයක බයික් එකක bend එකක් ගන්නවා නම් friction එකකින් වගේ එකකින් ගන්න ඕන නේ. ඒ විදිහට තමයි ගන්න. හරිද? And in the circular motion there is another force called centrifugal force. ඔව් එළියට තියෙන force එක. ඒ කියන්නේ centripetal force එක තියෙන toward the center නේ. Centrifugal force එක තියෙන්නේ outward the center, right? Because when the object some of a force is acting toward the center, to make it even, there has to be a reaction force, right? There has to be a reaction force as well, right? තාපාරක් කියනවා. අය කියනවා මෙන්න. දැන් මෙයා අපි හිතමු circular motion එකේ යනවා කියලා. මේ circular motion එකේ මෙයා යනකොට center එකට තියෙනවනේ force එකක්. ඒකට අපි කියනවා centripetal force එක. දැන් centripetal force එක තියෙන්නේ towards the center නේ. දැන් මෙයාව towards the center අදිනවද? අදිනවා කියන්නේ සම්පූර්ණයෙන් මෙහෙම එනවද? එන්නේ නැහනේ. එන්නේ නැත්තේ ඇයි? Because there has to be a reaction which we call centrifugal force, and two of these forces should be equal. Right? Oh, ඒක තමයි centrifugal force කියන්නේ. Centripetal force එක කියන්නේ towards the center තියෙන force එක. Centrifugal force එක කියලා කියන්නේ outward the center තියෙන force එක. මේ two of the forces should be equal. And accelerations are also there. the acceleration toward the center is centripetal acceleration. Acceleration outward the center will be centrifugal acceleration. Do you get it? Now there is something called what? International Space Station. Have you heard of it? There's an international space station that people go there to that space station and they live in that space station. It's like a shuttle, a huge shuttle that they can live on it, right? So it is made like a cartwheel, you know, it's made like a cartwheel. මෙන්න එහෙම cartwheel එකක් වගේ තමයි හදලා තියෙන්නේ. හරිද? Let's say like something like this. I saw it in a film like this, and I did it like this. So it's something like this. It's a cartwheel, like it's a not the exact structure, but something like this, right? So it's rotating, right? This one is rotating. Now what happens when it rotates? It's make a circular motion, and in a circular motion, it has a centripetal force towards the center. And if an object is there, there is a centrifugal force outward that object as well. So මෙයා rotate වෙනකොට centripetal force එක තියෙනවා. ඒ කියන්නේ මේකේ ඉන්න එක්කෙනෙක්ට centrifugal force එකකුත් තියෙනවා. හරිද? එතකොට අපි හිතමු let's say a man is, now this is a flat surface. හරිද? Flat surface එක. අපි හිතමු there is a man here or a person here. Right? දැන් මෙන්න මේ accelerate දැන් මේ rotation එක සිද්ධ වෙනකොට there is a centrifugal force acting on the person. හරිද? එතකොට එයාව ගිහිල්ලා මොකද වෙන්නේ? මේ surface එකට තද වෙනවා. තද වුණාම surface එකෙන් තමයි centripetal force එක දෙන්නේ. Do you understand that? ඒක relative motion එකක්. ඒ කියන්නේ මෙයා rotate වෙනකොට එයාගේ centripetal force එක තියෙනවනේ. ඒ centripetal force එකට relatively එයාට centrifugal force එක හම්බෙන්නේ. පිටිපස්සට.
ඒකෙන් එයාකට විසි වෙනවා ගිහින් කොනේ වැටුණාට පස්සේ
වැදුනාන් පස්සේ centripetal force එක එතනින් හම්බෙනවා. හරි. ඒක අර ඔය දැකලා තියෙනවද දන්නේ අර මේ චයිනා වල ජපාන් වල එහෙම තියෙනවා rotating shell එකක්. එයා හයියෙන් rotate වෙනකොට එයාව ගිහිල්ලා wall එකට තද වෙනවා. ඒ කියන්නේ මෙහෙම cylindrical shape shell එකක් තියෙන්නේ. carnivals වල එහෙම තියෙන්නේ. ඔව්. අන්න හරි. ඒතර මේකේ කවුරු හරි මිනිහෙක් ගිහිල්ලා මේකේ හිට ගන්නවා. හරි. හිටගෙන මේක rotate වෙනවා. rotate කරාම එයා මෙහෙම wall එකට මොකද වෙන්නේ? wall එකට තද වෙනවා. හරිද? ඊට පස්සේ wall එකට තද වුණාම ටික වෙලාවකින් මෙන්න මේ පල්ලෙහා තිබ්බ මේ flow එක අයින් කරනවා. ඒක යට වෙන ප්‍රපාතය වගේ තියෙන්නේ. මෙයා මොකද වෙන්නේ? මෙයා wall එකට තද වෙලා ඉන්නේ. හරිද? ඒ තද වෙලා ඉන්නකොට එයාගේ අර centripetal force එක තියෙන center එකට. ඒක හම්බෙන්නේ කොහෙන්ද? wall එකේ. wall එකෙන් තමයි හම්බෙන්නේ. එතන මේකෙත් එහෙම එකක් තමයි වෙන්නේ. මෙයා මොකද වෙන්නේ? මෙන්න මේ wall එකට ගිහිල්ලා තද වෙන්නේ centrifugal force එකත් එක්ක. centrifugal force එක එළියට තියෙනවා. ඒ wall එකට තද වෙනවත් එක්කම centripetal force එක ඇතුළට හම්බ වෙනවා. ඒ දෙක equal වුණාම පස්සේ තමයි යාට stationary විදියට ඉන්න පුළුවන්. හරිද? දැන් ඕක ওই විදිහට තමයි stationary මේ space station එකේ තියෙන්නේ. දැන් අපි දන්නවා අර object එකේ තියෙන ඔය තියෙන centripetal acceleration එක equal වෙන්නේ මොකටද? Centripetal acceleration is equal to v square over r නේද? දැන් ඔයා මෙන්න මේ v square කියලා කියන්නේ tangential velocity එකනේ. ඒ tangential velocity එකයි radius එකයි. හරි. මෙන්න මේ radius එකයි. හරි. මේ center එකට තියෙන radius එකයි මෙයාගේ velocity එකයි. ඔයා හදනවා acceleration එක equal වෙන විදියට 9.8 meters per square second වෙන විදියට. හරිද? acceleration එක 9.8 meters per square second වෙන විදියට. මේ මොකද්ද? acceleration of gravity. එතකොට සෙන්ටර් එකට තියෙනවා මොකද්ද? ඔන්න ඔය ඇක්සලරේෂන් එක. ඒ හින්දා මෙයාව ගිහිල්ලා ප්‍රෙස් වෙනකොට ග්‍රවුන්ඩ් එකට. හරි. එයාව ග්‍රවුන්ඩ් එකට ප්‍රෙස් වෙන්නේ ග්‍රැවිටේෂනල් ඇක්සලරේෂන් එකට equal acceleration එක. ඒක එන්නේ අර centrifugal force එකේ. එයා ගිහිල්ලා ඒ වෝල් එකට ප්‍රෙස් වුණාන් පස්සේ රියැක්ෂන් එකක් එනවා සෙන්ටර් එක පැත්තට. ඒක තමයි යාගේ centripetal force එක. ඒකින් තමයි එයා ස්ටේෂනරි විදියට ඉන්නේ. දැන් මෙයා හිතන්නේ එතකොට මේ වෝල් එකේ මෙහෙම වටේ කැරකෙනවනේ. ඒ කැරකෙනකොට එයාට අර තියෙන centrifugal force එකෙන් එන acceleration එක gravitational acceleration එකට equal කරොතින් දැන් මෙයා මෙතන ඇවිදිනකොට මේ radius එකේ හැමතැනම ඇවිදිනකොට අපේ equation එක මොකද්ද? v square over r නේද? v square එක constant නම් r constant නම් acceleration එක වෙනස් වෙනවද? නැහැ. ඒතර එයා මේ ඇවිදින හැමතැනකම එයාට දැනෙන්නේ මොකද්ද? gravitational acceleration එක. එතකොට එයාට මේක අර කාට් වීල් එකක් නම් මේ කාට් වීල් එක අර ඇතුලේ උඩ තියෙන ෆ්‍රේම් එක දිගේ ඇවිදින්න පුළුවන් අර්ත් එකේ ඇවිදිනවා වගේ. එතකොට අර
හැම පොයින්ට් එකේදීම අර
ඒ ඇක්සලරේෂන් එකම තමයි තියෙන්නේ. හැම පොයින්ට් එකෙම වෙනවා. ඒ කියන්නේ දැන් මෙයාට එනවනේ සෙන්ට්‍රිෆියුගල් ෆෝස් එකක්. ඒ සෙන්ට්‍රිෆියුගල් ෆෝස් එකේ ඇක්සලරේෂන් එක මෙච්චරයිනේ. ඒක අපි හදාගත්තේ මෙයාගෙන්නේ v square over r ගෙන්නේ. ඒතර අපි රේඩියස් එකයි වෙලොසිටි එකයි හදා ගන්නවා. ඒ ඇක්සලරේෂන් එක 9.8 එන විදියට. correct? ඒ කියන්නේ මේ පැත්තට කියන්නේ නෑ නෑ ඒ ඉන්නේ reaction එක. Because in that case reaction is keeping the circular motion but the force outward is the force keeping the person on the touch on the ground. ඒ කියන්නේ centrifugal force එකෙන් තමයි යාව තද කරලා තියාගන්නේ surface එකට. ඒකෙන් එන reaction එකෙන් තමයි මේ circular motion එක කියන්නේ. So what? Perpendicular force එකක් කියන්නේ කොහෙන්ද?
ඒතකොට gravity එකත් එක්ක තියෙන සම්බන්ධය.
ඉතින් ඒතකොට gravity එක වගේනේ. අයි මේක මේ කාට් වීල් එකක් ස්පේස් එකේ තියෙන. එක තැනක තියෙනවා. ඒතකොට මෙයා මෙතන ඉන්නේ. මෙතන හැබැයි එයාට දැනෙන acceleration එක කොච්චරද? 9.8. එතකොට එයා මෙන්න මේ radius එකේ මේ දැන් මේක සම්පූර්ණයෙන් rotate වෙන්නේ v square over r වලින්. එතකොට මේ
r එකෙන් කොහොමද 9.8 හදාගෙන එතකොට ඒක දුන්නට පස්සේ ඒක හින්දා අතලින් හම් වෙන centrifugal force මේ centripetal force එක 9.8
8 වෙනවා.
ඒක මේ අතරදී.
කොයි අතරද? ඉතින් එහෙට තිබ්බොතින් එයා දැන් මෙහෙට නම් කරකෙන්නේ එයා දැන් මේක නම් කරකෙන්නේ මේ කම්ප්ලීට් එක නම් කරකෙන්නේ මේ වෝල් එකේ තමයි එයා ඇවිදි මේ ක්‍රොස් වෝල් වල ඇවිදි ඔව් 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 එතකොට දැන් මේක නම් කරකෙන්නේ එයා මෙන්න මේක දිගේ ඇවිදි මෙහිම ඇවිදි මොකද ඇක්සලරේෂන් එක එන්නේ ඔව් in that case ඒතර ඒගොල්ලෝ බිත්තියක විදිහට තින්නේ ග්‍රවුන්ඩ් එක හදලා තියෙන්නේ. ඒතර එයාට gravity එකට equal acceleration එකක තියෙනවා. So it feels like walking in the earth. මේ concept එක තමයි පාවිච්චි කරන්නේ. So simply ඔව් මේ radius එකෙන් මේ velocity එකෙන් කරගෙනවා. ඒතර එයාට එහෙම තමයි. මම එහෙම කිව්වේ නැද්ද? ඒ බිත්තිය වගේ දැන් මේ ටිකේ තමයි පොළොව තියෙන්නේ. මෙයා මේක තමයි ඇවිදින්නේ. මේක දාර දිගේ තමයි ඇවිදගෙන ඉන්නේ. right? ඔව්. එතකොට දැන් අපි පිටින් ඉඳන් බැලුවොත් අපිට පේන්නේ මේ මිනිස්සු ඔළුවෙන් ඉන්නවා වගේ. හැබැයි එයා ඉන්නේ අර gravitational acceleration එක. Understood it? Bit of a somewhat understood it. People circular motion එකක් talk එකක් දෙද්දී acceleration එකක් වෙනවා කිව්වා. ඒක different. Now online people, did you understand it? Bit of a, I know something to me. Yes. චුට්ටක් කල්පනා කරලා understand කරන්න ඕන එක. ඈ? හිතන්න බෑ අදාහගන්න බෑ වගේ අදන people online, did you understand it? You haven't understood it. Thumbs up. Okay. Shiny, Sadesh. Yohasa especially. Yohasa is like, I know. Yohasa must be telling something to me. No. Right. ඒ theory එකකින් ඔයාට question එකක් එන්න පුළුවන් chance එක very less, හරිද? Very less, but understanding that theory is very important. Understood, Johan? Only Johan understood it. None of the others understood, bro. Johan is doing thumbs up for everything. I can't trust this big person. Bro, Johan, are you for real? You understood it? Let's see. Like now, if the people didn't understand it, you just tell me. Yeah? So centripetal and centrifugal acceleration is this, and I'll be doing some of the questions sort of like related to it, and you try to understand at least by then. I'm serious. Are you serious? Okay. Jan is serious. All right, bro. Right. So come to this part, the centripetal force. So the centripetal force, the force acting towards the center. So what is the force in a formula? Force equals F equals ma, mass into acceleration. So if we know the acceleration, you multiply it by the mass, you get the force. So this is it, right? To maintain any circular motion, the acceleration toward the center should be supplied by any means of force. The force required for centripetal acceleration is called centripetal force, which is equal to V square over R you have to multiply it by mass. So you get mass into V square over R, which is the centripetal force, right? Which is the centripetal force. And this is V square over R, we already know it, right? V square over R, yes. So you multiply it by the M, you get centripetal force. Huh? No. Make a V square over can acceleration. Okay, mass वली multiply करा force. Right. If මේ අපි කතා කරන මේ circular motion එක වෙන වෙලාවල් හොඳයි. If a mass tied to a string is rotated in a horizontal plane, the centripetal force caused by the tension in the string. The centripetal force is the tension of the string. Yeah, right. Centripetal force is the tension of the string. We discussed it, right? When a planetary body moves around the sun, or when a satellite moves around a planetary body, the force caused by the force caused by is the force of gravity, and the acceleration of vehicle traveling at a constant speed on a circular horizontal road is provided by the force of friction. Likewise, any of the force has to give the centripetal force, right? Understood, father, bro. Put FR. That's FR is like father, right? For real. I said. So we usually say father.
FR is for real.
Understood, FR. Other father, I said, Jesus, no. Yeah. For real, okay. That's a gene trouble. Do the questions. We'll see like how your understanding level is, right? Try the questions. The rotating board at rest rotates through an angle of 100 radians in 5 seconds by applying a force of 25 newtons, and its radius is given 2 meters. Find the torque. තනියෙන් කරගෙන board එක තන. Likewise. So you have to find radius is 2 much. Find the torque. First thing is to find the torque.
So make a inertia එකට formula කොහොමද?
FR දාලා කෙනෙක්ව ගන්නේ?
Inertia එකට නෙමෙයි. ඒක තමයි ඒක inertia එකේ formula එකකින් fourth එකේ inertia දාන්න inertia formula දාන්න නැතුව හොයන්න විදියක් ගැන කල්පනා කරන්න. Can do it that way, ne? Can find the acceleration. People try it by yourself. සර් ටියුට් එකේ question ටික ලියන්න ඕන සර් blank page එක. Bro, I'll give a new tute because in the new tutes all the questions are there. Johan Januka is okay. So me use the screen. The question is here. You can see it, right? මේක පේනව නේද? Okay. For now use the screen. The questions හතරයිනේ තියෙන්නේ හතර කරා.
So okay මේ third එකේ fourth එකේ මේ answers පොඩ්ඩක් වැරදිද කොහොමද?
Maybe third fourth answers මේ ඔයගොල්ලන්ට එන එක බලන්න, don't consider the answers given. Maybe it's not sure. හදන්න අපි ඊට පස්සේ කතා කරමු. ගොඩක් වෙලාවට ටීචර්ස්ලා ඔගේ ඉක්වේෂන්ස් ටික විතරයි දෙන්නේ. centripetal force, centrifugal force වැඩි ඩිස්කෂන් එකකට යන්නේ නැහැ. මොකද sometimes දාතේ
මේකේ අපි දැන් මේ structure delay වගේ questions
හ්ම්
5 එක simplify කරන්න ඕනේ නැහැ.
ඕනේ. Sorry. Just give me a second. Done? Finish. Hey, shall we discuss it? Any of the peoples? Right, a rotating board at rest is rotated through an angle of 100 radians per 5 seconds by applying a force of 25 newtons. Its radius is 2 meters, right? And they are asking to find the torque. So what is torque here? The radius is given and the force is given, so you can put Fr, right? So the torque equals Fr here, right? Even you can put the simple R, doesn't matter. So torque equals, force is 25 newtons and the radius is 2 meters, so that will be 50 Newton meters, the torque. Got it? Nice. Then find the final angular velocity. How do you find the final angular velocity? It says rotating board at rest is rotated through an angle of 100 radians per 5 seconds by applying a force of 25 newtons.
Angular displacement change over
Yes, angular displacement change over time. So that's delta theta over t, right? So the angular displacement change is 100 rads and the time taken is 5 seconds. So that will give 20 rads per second, right? Rads per second. Right. Then find the angular acceleration. So how do you find the angular acceleration?
omega change over time.
Yes, the velocity change over time will give the angular acceleration. So angular acceleration equal to delta omega over time. So that will be, delta omega is how much? 20 rads per second is the final, initial is 0 and the time taken is 5 seconds. So that will be 4 rads per square second, that is the acceleration. And find the moment of inertia. So you have the torque, you have the acceleration, the moment of inertia is what? Tau equals I alpha. Tau equals I alpha. So torque is how much? 50. And you have to find I, and the alpha is 4 rads per square second. And the I is equal to 50 over 4, which is 12.5. 12.5 kgm square. This is the answer. Understood it? Just only have to just change the equation and take the values. Right? So people online, did you understand it? Johan? Got the answers? Right? Shall we try this one? Yeah. Or else can you try this at home? We'll discuss the next week and come to the angular momentum, right? So we can finish the theory, right? Come to the angular momentum. Yes, Johan got it, right? So the angular momentum. Now, what is angular momentum? Angular momentum. It's same like the linear momentum. Linear momentum is what? Mass into velocity. So instead of mass, we are using I, which is the moment of inertia, and instead of velocity, we are using the omega, right? Angular velocity. So wait up. So P equals mv, which is linear momentum is mass into velocity. So if I take the angular momentum, say angular, it will be mass is I, moment of inertia, and the v will be omega. What does it say? The moment of inertia into the angular velocity. So this means something, we understand it. Now when it comes to the linear motion, we discussed it a bit. When it comes to the linear motion, mass into velocity happens when a force is applied. So when a force is applied, oh, sort of or something like that, yes. So now when a force is acting, the actual thing that changes is not just the mass anyway doesn't change, and not only the velocity, but the mass into velocity together. That is the factor. ඒ කියන්නේ force එකක් apply කරාම mass එක කොහොමද change වෙන්නේ? velocity එක තනියෙන් change වෙනවා කියන එකත් නෙමෙයි. mass and velocity එකට change වෙනවා කියන එක. ඒ කියන්නේ momentum එක change වෙනවා කියන එක. So momentum is one unit. Momentum acts as a one unit. So when a force is applied, the complete momentum is changing. The mass into velocity factor is changing because mass එක කොහොමද වෙනස් වෙන්නේ? ඔව්. නිව්ටන්ගේ second law එක කියන්නේත් ඒක තමයි. කියන්නේ mass and velocity together තමයි change වෙන්නේ. ඒක තමයි effect වෙලා තියෙන්නේ. mass and velocity කියන දෙන්නම තමයි change වෙන්නේ. momentum කියන එක තමයි change වෙන්නේ. ඒතකොට momentum කියන්නේ එක fact එකක්. හරිද? එතකොට මේකෙදී angular momentum එක තමයි change වෙන්නේ. ඒ කියන්නේ අරගෙදි force එකක් apply කරාන් පස්සේ let's say you are in the space. How we are taking someone to the space. Who's going to space? Johan going to space. Easiest man to get into the space. Johan goes into the space, right? And Ravishka takes him to the space and kicks him the butt. What happens to the Johan? Johan will be moving linearly. Nothing would stop him. Get it? Nothing would stop him. He will be moving linearly. So his mass is moving with the velocity. So because of the force, what did he had? Mass and a velocity. Now if Ryan was there and he kicked with the same kick, now the Ryan will also be moving. But would it be the same? No, his mass and velocity are changed. So the velocity is affected by the mass, isn't it? So because of that, we are not only considering the mass, instead we are considering the mass into velocity multiplication. Understand it? So that is momentum, right? When a force is applied, momentum is changed. Understand it? Same way, the moment only can be changed applying another external force, right? The Johan කාටවත් නවත්තන්න බෑ space එකේදී because he is moving with the velocity because the force applied by Ravishka. Now he is moving, so nothing can stop him because he is in the space. No forces are there to stop him. But if someone wants to stop it or to change his direction or to slow him down, have to apply a force, right? So if someone is applying a force, what happens to Johan? Either he will slow down or accelerate kind of a thing will happen. So for all of that, his mass into velocity has to change, isn't it? So when the force is applying, not only the velocity is changing, mass into velocity whole unit is changing. Do you understand that? The mass into velocity whole unit is changing. Mass into velocity is changing, which is momentum, right? So momentum changes when a external force is applied. Do you get it? Momentum changes when external force is applied. That is why Johan is moving in a constant momentum, because there is no external force after the kick. If there was any external force after the kick, his momentum will change. But now his momentum isn't changing because there is no any external force. So this theory says what? Without an external force, the momentum doesn't change. So the momentum has to be constant. That is the law of conservation of momentum, which means without external force, the momentum has to remain constant. Get it? Somewhat understood something? Johan? So mage weight එකට උඩට යන්නේ නැති වෙස will anyway how somehow we let's say කොහමද ගෙනාවේ කියලා හිතමු ඈ අදට එකක් ගියොත් ඔව් හන්දට එකක් යනවා ඊට පස්සේනේ ගහන්නේ right. So now this is the thing. So without external force, the momentum doesn't change. Do you understand it? Without external force, the momentum doesn't change. Same way, in the circular motion, instead of momentum, what is there? No. Yeah, the angular momentum is there, right? The angular momentum is there. The I into omega is there, right? Angular momentum is there, I into omega. The I into omega or the angular momentum, same like the mass into velocity. Angular momentum can only be changed with the external force or a torque. With the external torque, because in the circular motion, instead of force, we are using torque. Force is like the torque. In the circular motion, instead of torque, instead of force, we are using torque. So they are more like. But in the circular motion, instead of force, we are using a torque. So without an external torque, the angular momentum won't change, which means I into omega won't change. It will remain constant if there is no any external force is applied. That is called the conservation of angular momentum. So we are going to do a practical now. Now the few of the people are missing, I don't know, but huh? Somebody has to rotate me. Bro, come with the masses, right? So I'm going to prove it. Right, so I'm in a rotating disc. It's actually a chair, but you know, I can rotate, right? Yeah. So what I'm going to do is, I'm going to prove it that the angular momentum doesn't change, right? Because like without any external force, right? Which means now අපි හිතමු මේකේ දැන් friction එකක් නැහැ කියලා. හරිද? දැන් මේ මම මේ rotate වෙන object එකේ friction එකක් නැහැ. ඒ කියන්නේ friction එකක් තිබ්බොත් තමයි ඕනම එක slow වෙන්නේ. අපි පොළොව දිගේ මොකක් හරි යවුවොතින් because of the friction it will slow down. That is the external force applied, right? Okay. That is the external force applied, right? So now in this case, just may rotate, but wait, I'll tell. Right? So in this case, like make a friction එකක් තියෙනවා මේ chair එකේ friction එකක් තියෙනවා නැත්නම් මේ rotating disc එකේ friction එකක් තියෙනවා. Because of that, this will slow down. But if it wasn't there, this will be rotating constantly in the same momentum. Mass into velocity or the I into omega will be same, should be same if there's no friction. I'll make a frictionless in the, just may show rotating me, it will be rotating, right? In the same momentum. See, doesn't stop for a long enough, right? Now because of the friction, stop, right? Because of the friction, this wheel is slow. Now he stopped dead, but usually it slows because of the friction. Now the friction is the external force. If there was no friction, I'll be rotating forever with the same angular momentum, right? Now this is the theory. Listen, you come back to the seat for a second, right? This is the theory. If no external force is applied, right? If no external force is applied or a external torque is applied, I omega has to be constant, right? I omega has to be constant. Let's say it's k, right? I omega has to be constant, it's k. So shall I take the, like, if I take I as 4 and omega as 3, the constant value will be 12, right? So let's say this is me rotating, my moment of inertia is I, omega is 3, right? I'm rotating in this 12, now 12 value of a what? Angular momentum, right? 12 amount of angular momentum I was rotating. Then external force එක නැත්නම් this 12 amount of value should be constant. හරි. මේ 12 amount of value should be constant if there is no external force is applied, right? ඒක නිසා මම අර එකම momentum එකෙන් කැරක් ඉඳී. And without any of the external force, freezed. What's happened? Does it happen to the online people as well? So it's so ni like we know. Another broken to can put make like we know. දැන් හරිද එකපාරට ලැග් වෙනවා ඇයි නෑ ඩිලේ එකක් තියෙනවනේ දැන් හරි කිව්වට හරි නෑ ඔව් අපිට එමුණොත් moment of inertia එක next week නේ පොඩි ලැග් එකක් එනවා කුලේ නැති අවුල තියලා තියෙන්නේ නෑ නේ ලැග් එක තියෙනවා RAM එකද? RAM එක මදිලාද? එහෙනම් වැඩ කරන්නේ මොකද විදිහද? හා. දැන් හරිද? එහෙනම් RAM එකේ අවුලක් තියෙනනේ. දැන් හරි. රොස් දැන් හරි නේද? ये कॉल करना थे Hari, then Hari. So we'll discuss it anyways in the next week as well, but for now try to listen, right? So this is what happens, right? Then external force එකක් නැතුව තම මෙහෙම තියෙන්නේ. හරි. external force එකක් නැතුව තියෙද්දි මම මෙන්න මේ moment of inertia කියන එක වැඩි කරොත්, let's say I'm increasing the moment of inertia, let's say I'm increasing this to 6, right external force එක නැතුව මේ කරන්නේ හොඳ කියන්නේ කවුරුත් එළියෙන් මුකුත් කළා නෙමෙයි no external force moment of inertia එක වැඩි කරනවා example එකක් විදිහට මම දැන් මෙහෙම කැරක් ඉන්න ගමන් අත් දෙකෙන් මොකද කරන්නේ moment of radius එක වැඩි කරනවා එතකොට moment of inertia වැඩි වෙනවා moment of inertia වැඩි වෙනකොට මෙයා 12ම තියෙන්න ඕන මොකද external force එකක් ආවේ නැති හින්දා එතකොට මොකද වෙන්නේ මෙයා 12 ඉන්න නම් ඔමෙගා මොකද වෙන්නේ ඔමෙගා 2 උනොත් තමයි මෙයා 12 වෙන්නේ ඒ කියන්නේ ඔමෙගා මොකද වෙන්නේ අඩු වෙනවා මෙන්න මේ මේක කන්සර්ව් තියාගන්න නේ ඒ කියන්නේ angular momentum එක conserve තියාගන්න මම moment of inertia එක වැඩි කරපු ගමන් velocity එක මොකද උනේ අඩු වුණා right ඒක අනිත් පැත්ත කරොත් මම moment of inertia එක අඩු කරොත් 2 වෙනකම් එතකොට ඔව් omega මොකක් වෙන්න ඕනද 6 වෙන්න ඕන මේක 12 වෙන්න ඔව් ඒ කියන්නේ external force එකක් නැත්තම් 12 එක constant තියෙන්න ඕන අපි ඒක ඕන practically කරලා පෙන්නන්න පුළුවන් කොහොමද කියලා හරි දැන් මම මේ කියප එක we can practically do it right how මේ තියෙන්නේ නිකන් අපි මාව කරකවල පෙන්නන නිකන් වදින්නේ නැහැ නේද මාව කරන්නේ right so this is a just a circular motion and the bro stop it right and the angular momentum is constant doesn't change because no external force is applied so it will be rotating should be rotating in the same motion right with the same angular momentum and while it's moving I'm going to change my moment of inertia which is the distribution of mass now if I increase the hands like this what is name නෑනේ කරකවල බලන්න වදිනවද කියලා නෑ වදින්නේ හරි so if I increase the no stop it bro right if I increase the radius or the mass distribution the moment of inertia will be more right and I decrease the radius the moment of inertia will be less like in the equation I gave you මේක වැඩි කරොත් මේක 6 වගේ වෙනවා. එතකොට හරියනම් velocity එක මොකක් වෙන්න ඕනද? අඩු වෙන්න ඕන. මේක මෙහෙම කරොත් moment of inertia අඩු වෙනවා. ඒක හරියට නිකන් අර 4 තිබ්බ එක 2 වුණා වගේ. එතකොට මොකක් වෙන්න ඕනද velocity එක? velocity එක වැඩි. physics හරියනම් ඒක වෙන්න ඕනේ එහෙම. shall we try it? එහෙම වෙන්න ඕන හරිද? ඔය moment of inertia කියන එක sorry the angular momentum කියන එක conserve වෙනවා නම් external force එකක් නැතුව තියෙද්දි මේ අපි කතා කරපු එක වෙන්න ඕන. Shall we try it? Look. Slow වුණා නේද? Now what happened? So you say it happens. So it's true, right? So the physics is somewhat true. Yes. Good. Johan, did you see it? There's a message pop up, so I don't see it. I don't see if the Johan text back. Right, so yes, nice, okay. So Yohasa is there? Yeah, Yohasa is there. Sadish is there? Did you understand it? We'll discuss it back again the next week as well. But try to go through it, Google it, do some research, come with some knowledge. Yeah, ChatGPT it, DeepSeek it. Huh? Oh. තව තියෙන ගොඩාක් ඒවා තියෙනවා ඔකෙන් කරන්න පුළුවන් ඒවා. මම next week I will teach you how to do a spin. Like a balti. මම මෙතන ගහලා පෙන්නනවා බල්ටියක්. ඔව්. මම මෙතන බල්ටියක් ගහුවොත් නේද 10 දෙනෙක්ද? අර උඩ පැනලා මෙහෙම කරකිලා මෙහෙට වැටි. ඒක ඔව්. ඒක ඇන්ගියුලර් ඔව්. ස්පීඩ් ගන්න. ඈ? මෙහෙ ඉඳලා අනිත් පැත්තට ගහන්න. අනිත් පැත්තට වැටෙනවා. You can do it easily. Yeah. If you know the physics. For real. Right. So backflip, yes, backflip and front flip දෙකම ගහන්න පුළුවන් if you know the ඇති මං ලබන සතියේ යොහන්න ප්‍රැක්ටිස් කළා යොහන්න මෙතන බැක් ෆ්ලිප් එකයි ෆ්‍රන්ට් ෆ්ලිප් එක දෙකම ගාලා පෙන්නනවා යොහන්න. Right guys, then we'll see you next week with the final part of the tute and we'll be starting a new lesson. So adios people. We'll catch you. Now tell the management to come and close it. People, adios. We'll see you.